Good evening. Wi-Fi. We looked at the concept of a Wi-Fi, and today security issues of Wi-Fi. Um, well, already some security issues dealt with, for example, authentication. When they when your laptop try to associate with AP access points, then the authentication should be done before you do. Today, we'll look at encryption technique. Encryption technique that you probably learned from a separate course, cryptography. Sometimes you, uh, depending upon the instructors, right? Sometimes they cover up to wireless encryption. I mean, the data streaming encryption and wireless data encryption. Today we'll look at only wireless encryption techniques. .802.11, the Wi-Fi. The security suites implemented for it is WEP. And the algorithms that we are going to learn today is only WEP. So knowing WEP, you can imagine the advanced technique from there. So WPA and WPA2 is the extension from, or the technique overcome resolving WEP issues. So after we learn the algorithms, encryption technique of WEP, we'll do a real hands-on. It's not really hands-on. Computation by hand. But you could do that by programs. I implemented that the last, a year ago, but hmm? Right, right. So what we will do, we'll spend underlying concepts of this, and also evolution of that is this, is RC4. RC4 algorithm will be learned extensively and some practice also. I wanted to recall the Wi-Fi technique. You have a station, your laptop, and AP, access points. Behind it, there is a wired communication. And therefore, you can go to another network. And finally, there is another access points. And therefore, there is laptop at the other end of this whole communication line. So what we learned the last time is access points keep sending out beacon signals, and then your station may want to, your station respond to that. And then for way of handshaking, they can communicate. But because of there is collision in wireless communication, so wireless technique developed the collision avoidance rather than collision detection. You learned it why, right? It is simple. We better avoid it Otherwise, station is moving. There's no way that they can definitely re-request the message which has some collision. Architecture of a wireless network. We looked at this last week. Same slide, but in different organizations. For you to recall, there is a service area we call the cell area, right? Usually there is an octagon shape in our representation. Usually, right? Octagon. So that we can represent another in that octagon very nicely. This is just our representation, pictorial representation. It doesn't mean that real cell covers this way, octagon shape. There's some overlays. There is also, I didn't cover that in this semester, but for example, setting up antenna or AP, access points, we can calculate how many access points that we need to establish to cover a certain area while we have certain energy and frequency band, and therefore carriers are available. But anyway, it covers. If I have access points here, then it covers that much, right? Man in the middle for wireless communication. As far as wireless communication, that's fine, right? What he wants is that we have a group project, not only you students in class, but also online. Students can meet and discuss online also to meet the group. And you need to form a team, and each team needs to conduct the research and then make a presentation. That is your final exam. The midterm exam will be given to you first or second week of November. It's pretty much a comprehensive exam. Possibly open book, 99.9%. But there is always a miracle, 0.1% miracle. You are so smart. Oh yeah, everything. Yeah. Yeah. Project. No. Um, multiple solution. How about that? Open question. Project during today's break. I want you to form a group, and therefore I'm going to post what you need to do. Once you have a group, then you need to submit a proposal. Um, by reviewing all the work that you learned so far, and if you have any interesting issues so far in this program or from anywhere or from your work, if you want to do more study or some prototype, Uh, whichever will be okay. If some group wants to do only survey, reading articles, and then show compare and contrast, and comparison and contrast that you may make is new, no one has done before, then that is your contribution. But I strongly recommend you to do a little bit of implementation. While you develop some issues, if you find some small concept there from the many different concepts in your research scope, if you find any single small but wants to implement, wants to verify, wants to prove such concepts, I strongly recommend you to do some proving work. You can prove it. The easiest way of proving is doing some programming. Python programs is doable usually. The hardest part of that is hardest part, but less likely useful is the theoretic proving. You could do that too if you have strong math background. Anything that you want, right? So those who do not have any technical merit or talent or gift, whatever, then you could do reading more and more materials, articles, papers, research papers, journal papers, and get more knowledge from there and write that up. That is your group project. Okay. Yeah, you need to make a presentation. Hopefully, we will have a presentation, not only you here, but online students all together. Online students can do, they can make their own presentation, and the easiest way is that, but there are two ways, right? They can connect one of your laptop and then through the Skype or Google Hangouts, yeah, and then we can present it. No, yeah, I want to bring online students here to you, or some online students can produce video clips and post it on YouTube. Similarly, the way that I record my lecture here and post online, and then we can watch that here. That is fine too. I will give you the grading criteria, rubrics, so that you have to meet that rubrics. Sometimes you do not really care the rubrics. You need to meet all the points. If I give you some rubrics, some students miss so many easy things, therefore big points miss. Oh yeah, real demo. Yeah, that's even better, right? If you have a demo, if you have anything demonstratable, executable, then I want you to do that instead of formal PowerPoint presentation. Of course, you can start with a PowerPoint presentation and yeah, jump to your demonstration. That's even better, a lot better. I think final week will be yeah, mid-December. So around that time, I think that is our presentation day. If we cannot make one Thursday night, then we may do two Thursday nights. I think we need to plan two Thursday nights. if I have so many. Um, so what is the implication, David? Christmas time, so that we will have some. Oh yeah, that is a good idea. Yeah, we can we can make a Christmas parade with our implementation. Okay, so we have access points. We have uh, service set, basic service sets. And there are two types of service sets, right? Basic and extended service sets. Service sets usually is nothing but if we have a very simple Wi-Fi, then that is the title of access points. When you set up access points, then the name of your configuration of access points will be the name of that service set. Yeah, at your home, you may, yeah, Talib's home. That is service sets. That's ID, service set. It is not, right, it's not something that you can get from your home wireless router. You need a different wireless network equipment. For example, for medical purpose, then they have some extended, some hospital, banking systems, finance. They all they need some control, um, uh, the access to not only to communicate the data, but communicate the control. That can be done by extended. Yeah, because you want to control. I want to shut down this channel, that channel. Uh, like big, large volume of wireless router, for example, so that it can serve 1,000 people at one time. Then you can control. You need to have some control. Yeah. Okay. Oops. The services that you can get is association, disassociation between access point and station, usually, and also station sometimes reassociates. Um, some of the interchange of packets for special control mechanism, they may need to do this. And distribution, integration. Authentication is before station can associate or disassociate. Authentication process needs to be done between access points and this is access points. These are the station. So they need to get some, they need to be authenticated. And if they are not, then authentication is possible. For privacy preservance, encryption technique is used. But actually, if you see these services, there are two services are highly related with the security, authentication and privacy preservance. For privacy, encryption is really usually needed. For authentication, you need to be identified your identity and authorization needs to be done. So what do they do usually? If there is a Wi-Fi access, and usually they open free so that you want to associate, but server wants to make sure that you are associated. Therefore, there is this one simple procedures if it is open. If it is not open, then login and password needs to be provided and also authenticated. Even if it is not the case, then Wi-Fi usually asks you to agree whatever the policy they want to enforce, right? Simply, and then you can click done, then you are in that access. But only in such case, the problem is that connection, association is not guaranteed. It doesn't last long. So you have to reassociate from time to time. Okay, so before we get to the encryption technique, we need to learn some preliminaries. Binary code. Binary code. Any data to be transmitted can be written in binary. For example, cybersecurity. It's a text, right? I want you to see what is the binary code of cybersecurity. You got it? Yeah, that is right. Can you repeat it? There is another way that you could do is, for example, Python, if you are interested in, right? There's a Python program. I know you all installed Python on your laptop. Pretty much all, I guess, right? So if you still have that, then you can run. What?
This is the binary for cybersecurity. Oh.
So which website did you use?
Binaryexplorer.com.
Wow, very good. Another thing is, if you do this, then, oops. Unknown format code B for object type string. That's this. String equals cybersecurity. Format st, comma, binary. Oops. Unknown format B. B is the right format. We need to change it to okay. So what you need to do is a little bit of programming. Okay, that is in your class notes. So ST is cybersecurity, right? That is a variable. ORD is another function. If you put there, for example, capital C and B, then it returns. Oops. ORD X. You don't have to do. ORD C, then it returns the ASCII code of that character, right? One small c, one uppercase C, If there is a lowercase, then it's a higher number than uppercase, right? 67 is C and small c is that. So, and also um, format OLD capital C, and then if we say binary code, then it returns binary code. So uppercase C in binary code is 0, 1, 1, 0, 0, 0, and 0, I think 0, 1, 0, 0, and 0, 0, 1, 1. That is that, okay? So how can we make for this cyber security? You can do right. You can join. You don't have to, right? Format. Let's see. I have to do that, right? Yeah. So it should be join. So we need to join all the result of format expression, OLD, and whatever that X and B, OI in ST. Why join? Join is I want to convert cybersecurity in binary, and then I want to concatenate all of those results, because format, the function format can convert binary code per character, right? So this guy converts the ASCII code into binary. So OLD ordinary, so OLD ordinal number. OLD of character returns ASCII code, but format should return ASCII code for the first parameter, and second parameter is the type of the result or the format, so binary. I want to change this X one character at a time, which is therefore it should be X here. X in that's true. There's a array character or array ASCII separately, but OLD is it returns ASCII code. ASCII code for character, whatever character defined in the ASCII, that number is returned. In this case, yeah, we made it for loop. For example, if we do have OLD like this, uppercase C, then it returns a 67. That 67 should be placed as the first parameter for the function format.
And then B is like the format specifier.
Yeah, B indicates the format of the output. Output is in binary. That's what it is. But I need to do this continually for entire cybersecurity characters, one at a time, which means for one in that ST character. ST is nothing but character, right? Cybersecurity. See, ST, there's a cybersecurity. So if you return this, then it gives you this binary code. So what is your binary code that you have? No, 1000011. Did you do uppercase C or? right? So this number is sent out. Okay. So everything that you learned here in this encryption can be implemented in Python. If you extend this a little more, then that'll be your uh, impressive project. I want you to take your project to your interview. I'm sure your interviewer will be impressed at your work. Not many people could do this, right? Okay, let's do more. So that's what we learned. What about mercy? Mercy in binary. That's what we want to practice. I want you to do this. What you need to do? I can set st1 to mercy. And then I can do here, instead of st, I can do mercy1. Then there is a mercy. Similarly, if you want to do your name, I can change my name in binary code in this way. Yeah, it is considered space. Space is one of the ASCII code. No, look this. Format. First of all, what is the ASCII code of space? 32. 32 is the ASCII code for space. You can find it from, for example, ASCII table. There is ASCII table somewhere. And 32, see here? Did you see? 32 here. It says space, right? Decimal code 32. This ASCII code 32 is for space. So 32 needs to be converted to binary code. Can be converted to binary code. How can we do it? We can do format and OLD, that's space, and I want to change that to binary code. Then that is 1 0 0 0 0 0. So somewhere here there may be that. Where is the mercy? Mercy, John Yoon. Then 1 2 3 4 5 6 7 8. That is John J. 1 2 3 4 5 6 7 8. That is O. 1 2 3 4 5 6 7 8. O N. That is N. O I. That is I. And the N is 1 2 3 4 5 6 7 8. Some miscalculate somehow, I guess. So I think from here that is a space somehow, right? Or some leading zeros is omitted. J, for example, we can find that out, right? What is J? Small j. Is it small j? Uppercase J. Oh, it's not omitted. This is John. Let's try it. 1 2 3 4 5 6. 7, 8. Oh, my calculation is 2, 1, 2. So it's O, 1, 2, 1, 2, 1, 2, 1, 2. I, 1, 2, 1, 2, 1, 2, 1, 2. J, I. So we're a little confused. But anyway, this is 0. Okay. Let's continue. You did it? Great, 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 great. Okay. What about multimedia data? Audio and video. Are they all in binary or will be in different data format? Everything is binary. Everything. Everything. All the data, all digital. As far as the digital, then that is a binary code. So all binary, all binary. If you watch it, video clips or movies, they're all binary. There's also binary. You change, yeah, you can convert it to electrical signal, but there is a binary. So what do we mean by this? I mean, from the lessons that you learned so far, this is the code, right? This is a code for binary code for John Yun. And there is another code for example, cybersecurity. So one guy tried to send the cybersecurity, another guy tried to send the John Yun. And they want to come in the same channel of your frequency band. Then they need to mix it together, right? That's what we learned at a spread spectrum. No collisions. We need to multiplex it. No, same channel. What happens is that we add them. If both 1, then we add. So it'll be 2, right? Which means your device will generate double power. If there's only one single signal, then single power. If you have 2 signals mixed, then double. 3 signals, triple. All mixed. So that your signal will be finally like your signal will be as we looked last time, long time ago, sometimes like this and even bigger, right? So this will be your spread spectrum signals. This is spread spectrum signals.
Every time it goes up, it's because 2 signals are at the same time.
Correct. Right. So it depends on the code. If that is 0 or 1, for example, if there is 1, then usually negative voltages. 0, then positive voltages in the spread spectrum signals. Codification of this, for example, 0 and 1s, then we looked at the coding technique, right? So before you multiplex, you need to do coding, encode the signals. For example, Manchester encoding or bipolar encoding. That is on your homework assignments, right? Due is this Sunday night. Do not miss it. There is a binary code. Okay, hash function. What is hash? Everyone knows hash. Especially if you are studying cybersecurity, then hash is like a black box. If you want to say something secured, then you may be able to say Oh, we'll have a hash code. 50% of your answer will be correct.
Is it an integrity?
Yeah, it is checking the integrity. Um, yeah, can be used. Hash function can be used to check integrity, but a hash function itself is not really integrity checking. It's a mapping from arbitrary size data to fixed size data. Arbitrary size to fixed size, which means if you have so many inputs, million inputs, you could have 3 baskets, 3 buckets of data. The typical function that can tell or determine the hash is modulus. Modulus. Modulus is nothing, is a mod, right? What's a modulus? Modulus is nothing but remainder, right? Remainder of your division operation. For example, 17 divided by 3. Then 17 can be divided by 3, right? What is the quotient? 3 times 5, so 15. And the remainder is 2. So 2 is the modulo. For example, if you have 17 here, 17 comes. And then you can say this is a bucket 0, bucket 1, and bucket 2. And all the bucket number can be determined by the modulo. If it is 2, then okay, 17 goes to this bucket. If anything, the remainder is 1, then comes into this bucket. And same thing here. Sort of a classification, right? Three modulo of 17, what is the remainder? 17, 3 cannot be divided by 17. So everything will be the remainder, which is a 3, right? How come it is a 3? 3 divided by 17 equals 0 times 17 plus 3. So this is remainder. Same thing here. 17 divided by 3 means 5 times 3 plus 2. So this is the remainder. Why modulo is important? Why hash function is important in cybersecurity?
All integrity. For something it's not integral, you can use a hash.
If you have a hash here, then it's very hard to figure out the original data.
Not true. Because you have label tables.
For example, if you have number 2, so what is the original number?
What I'm saying is you have a label table, so you have three calculated hash values. So you have to reload a label table for any hash, maybe by hash, or shy number.
Still, it's not deterministic. How many original data is there? Unlimitedly many. How many numbers modulo becomes 2, unlimited. So you cannot imagine, you cannot guess the originals, which means in nature, this is secure. If you send instead of 17, for example, instead of 17, if you send the number 2, then no one can guess what is the original data. Original data is 17. Right? There's hash. Even if the same hash, it comes from different data source.
How do you make sure that something is not tampering? And I know they use hashes for integrity. Let's say you download the file and you show the file, you can take that hash.
Right. If you have the same source, then it returns always the same hash code. Right, but not the other way. Even if you have the same hash code, it doesn't mean that they are the same. It depends on the size of hash. Therefore, what is the length of that integrity check? I think 32 bit, right? 32 bit. Almost impossible to have those identical hash function. Right. It is. I mean, mathematically, almost impossible. So for integrity check, they use hash data. It tells you only that they are unique, but it doesn't mean that you can get the original. You cannot get the original data from your hash data, right? Always one direction. Undeterministic, because there are so many. So which one? Therefore, if you want to try all, it takes forever.
But what I'm saying is that a lot of these calculations happen because you can run a hash really fast. You have computers now, especially with big things.
Right.
So
Finding out hash function. Don't be confused. Don't be confused. Generating hash function is so quick. What I'm saying is that reverse engineering. If you have a hash function, can you get the original data?
that's what I'm saying.
No way.
You don't need that. If you have Lego,
No. Right. That is one way, right? But if you want to encrypt, if you use this function to encrypt, then encrypt will be highly likely secure. That is the point here. Okay, improvement here, dynamic. What I mean by here is look at this. We have static hashing and dynamic hashing. Okay. Static hashing that is being used for example, integrity check, hash code generator, or MD. What is MD? Some digest, right? M stands for MD function, then M, MD5, then D for digest, M for anybody? The acronym? Yeah, MD5, that is a digest, right? Okay. If you want to generate always 3 possible code, then static hash function, okay. Okay. For example, if you have MD5 code, then this modular is big number, so big number, randomly generated big number. Therefore, there's no, almost impossible to have these two will be in one bucket. Okay, so that digest program or data integrity checking program use different characteristics of hash function. They want to generate so many buckets. That is their concept. Okay, so whatever the inputs, they have a unique output. That is integrity checking. For encryption, it's the other way. You have so many inputs, but you have a limited output. So when you see your limited output, almost impossible to go back to guess the original data. For integrity checking, if you know this, then there is only one mapping there. Although you do not know the content, you know there is only one mapping. So if you have a little bit of change from this original, therefore you have totally different hash data. Therefore you make sure that if this hash data is not the same, then you can quickly, they are not the same, which means integrity is not preserved. That's not what we are trying to say here. Our concern here is encryption. Okay, how can we send the data? Therefore, they cannot guess the original data. So not all hash functions are functioning the same. Yeah, hash function is very, very powerful, so can be used to many different applications for different purpose. It's different purpose. I'm not sure dynamic hashing. We spent so much time here. So forget about dynamic hashing, right? Dynamic hashing is this. Idea is this. Modular here. If you look at the modular here, this modular is fixed. Number 3, whatever the number is fixed. Therefore, you have always limited well, there's a limited set. It's not infinite. Uncountably many limited set is obtained from this fixed static hash mechanism. On the other hand, the dynamic hashing, 2 to the power n is the modular. So depending upon the data, n is proportional to the data size. If you have so many data, then this modular will increase. If you have smaller sets of data, then n will decrease, which means you have right size of output all the time. So this kind of dynamic hashing is used for to increase the high performance of your computation when you use hash functions. Okay, particularly this idea has been developed in database community. When they search database, they want to search quick, right? How quick it is. If they have dynamic hashing, then database access is so quick. Yeah, that is dynamic hashing. Okay, okay, so modular. Can you practice in Python? Yes, you can do also. What is the operator? Operator is a percent sign. So if you go back to here, For example, 17 modulo 3, then returns 2. On the other hand, 7 modulo 3 modulo 17 and returns 3. So modulo is very, very simple in programming language. Simply percent sign, right? Now, you know bit binary code, and you need to operate. One of the operation highly used for the encryption is exclusive OR. Exclusive OR. Given to binary code. So any data can be converted to binary code, right? Any data. Now you want to make sure that data that you received through wireless communication is accurate, is genuine, there is no corruption during communication. How can you make sure that? Or, yeah, in that case, CLC is used usually, cyclic redundancy code. But you know the key, you know the encryption. So you receive encrypted cipher data in encryption. How can you decrypt it? Another assumption here is that in all wireless communication, time is important, right? When you receive the call from your cell phone, if your cell phone takes time to decrypt it, then you have to wait, right? There's a delay. But usually you never see any delay because it runs so fast. So internally, there's the exclusive OR operation is performed. What is the exclusive OR operation? What does it return? That is a bitwise operation. We call that bitwise operation. Bitwise operation. What is a bitwise operation? If we have two binary codes, for example, 1010 and 1100, two binary code, then they can apply that operator bit by bit, which means I want to operate this bit and apply that bit operation to the second bit and third bit and fourth bit by bit operation. That is bitwise operation. If they are the same bits, returns 0, different bits returns 1. For example, we have 2 bits, so bit by bit, first bit. If they are the same, then returns 0. If they are different, returns 1. And they are different, so returns 1. They are the same, therefore returns 0. If you apply that here, they are the same, so 0. If we apply exclusive OR, XOR, because they are the same, returns 0. If they are different, returns 1. They are different, 1 and 0 different, so it returns 1. 0 and 0, it returns 0. So result of that is 0, 1, 1, 0. Bitwise operation is very, 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 very strong tool, especially for wireless data encryption. And also you can speed up. Very quickly. Not only that, let's assume that this is the data. This is a key. This is a cipher that you received. Let's assume that this key is shared. Symmetric key. Which means sender and receiver both use the same key. Symmetric algorithm? I don't know what algorithm means in that case. Symmetric algorithm? Symmetric encryption algorithm? A symmetric key algorithm. Same key. I'm not sure what you mean by algorithm. Right. I'm not talking about that, but I need to see what algorithm that you are talking about. Symmetric, asymmetric encryption techniques, then that is in this technique. But algorithm sounds like there may be some algorithmic approach. Okay, so you have a key. So sender send this data. Instead of this data, and this C is received. Cipher is received. When receiver receives the cipher data, then receiver needs to understand the original. Original is D. They share K, right? How come the receiver can, by receiving this is the data that receiver receives. By using this, how can he get the original? He has the same key. Then simply use the same exclusive operator. So you can use 1100. That's the same key, right? And apply same exclusive OR. If they are the same, they are different, returns 1. If they are the same, returns 0. If they are different, returns 1. If they are the same, returns 0. This is D. I know that's wait. But right, that is the problem. How do you share the key, right? Key can be compromised. The key is not this simple, right? In our case, in our Wi-Fi, between access points and station, they share something, but both try to generate the key. So key generation algorithm is not known, shouldn't be released. So each company, if you have access points router and your laptop, then between those two, they share the same algorithm, which is not known by other laptop. But we will get to that. So what I mean by that here is that by receiving this cipher at the receiver side, they can get the original data. So C, this cipher is only the data that can be available along all the communication lines, right? So if they do not know this K, they do not get D, right? This is typical encryption technique. And that is the beauty of using exclusive OR operator. It is very fast. So now we have exclusive OR operator, and what this would be, we have two sets, two binary codes, 16-bit binary codes, right? Two binary code, but 16-bit, which means it represents two characters in ASCII. What is exclusive OR? Can you practice it right now by pen and paper or on your whatever the computer? No, do not run the computer. Probably, I'm not sure. Yeah, yeah, I will let you do open book and open resources, so that those who do not know how to calculate and get binary code still can get from some website. But you have to be very careful. If you run carelessly, then answer will be incorrect. If you show all the steps by calculating, then by hand, then you may get some partial points. But if you simply copy from the website to your answer sheets, then no. Your midterm exam, yeah, at your midterm exam. Some study guide. I don't know why you like a take-home test. You can relax here. Popcorn. Yeah, you can bring. We have some food here. Pile some food, and we can eat and take midterm exam. Olivia, you already got. Very impressive. Okay, so she got one. Anybody has any? Oh, we'll get to that. Let me see. Let me test if we could do that in here in binary code. I'm not sure. It is not. Probably not, right? Right. Um, if it's a binary. If there is a decimal, then this exclusive OR is okay. It returns one, right? So another way that we could do is format in a reverse way. Format. Not sure. This is possible. No. String. It's not possible. Which one? Not sure. Like this? Right. That is the issue. So what is your? Yeah, if it is a letter, yeah, that's fine. But what if we have a binary? Decimal? That's what I tried here. It's not possible. That's okay. So that's so so in binary you can manually uh, operate exclusive OR operation, and now we can do um, in Python as we did before, uh, convert the string into binary code, right? And those binary code can be um, right rather than right. If we have a string, for example, format any string a character a and b character b in binary. Oh, you need to right. You have to do integer. You need to change it in integer. Int to int. So b unknown format code b. Hmm. Format 17 in b for binary, then a is that, and b format, let's say 3 in binary, then b is that, right? And then we can as is, this binary cannot be, so 17 and 3, it can give you the exclusive OR. So actually what you can do is format that expression. You can do step by step. So C equals that, and then format C and binary code. Then you can see the binary code of 18. Right? So this is exclusive OR, and then the result will be converted to binary. So 18 is nothing but this. I think that is a simple expression of exclusive OR. So if you have two strings, then you can make it exclusive OR. It is simple because we have a number. What if we have two different strings? For example, A equals Mercy, B equals Mary, Mary Mercy. Of course, It's not possible, right? There's a string. So what you need to do is make it integer. So ASCII code. How can you make ASCII code? OLD, right? OLD A. No, one at a time. So that is the issue. So simply OLD A for A in, no, OLD I for I in A, then it returns. Oh, it should be print OLD I for I in A. Is it possible? OLD M. Right. Okay. 77. Okay. So what we could do is OLD I, OLD J for I and J in A and B. Oh, so greedy. If it works, it's great, but may not work. Am I so greedy? Yes. Invalid syntax. So somehow script is needed. So more than one sentence, right? Some for loops, somehow it is needed. Or you have to make zip so that you may have one statements. All right. So with that preliminaries, then we'll get to the encryption technique. Portable station moves from one point to another, but is always used as at a fixed points. Mobile station, there's a portable station. A mobile station accesses the LAN during the movement. So mobile services, as we looked at last week and this week, station has the services of association, reassociation, disassociation, distribution, and integration. This is not really station services. I think this is an access point also. And distributed system services, then from that distribution center, authentication needs to be provided. So authentication and deauthentication. And privacy, in other words, key needs to be provided by, or some algorithm needs to be controlled by distributed center services. So MAC service data units and delivery, that is also from the service center. WEP is an old technique. Is broken now, but the idea remains similar to the current advanced ones. Authentication and encryption, those two techniques are used, but we're not going to do a lot about authentication here because that is very, very straightforward. It goes back to the control center, distribution center, and distribution center authenticated. So it is much straightforward. Encryption is by the algorithm RC4 to generate a stream cipher. That is what we want to have here. So WEP authentication, before association, host needs to authenticate itself to access points. So authentication procedures is as follows. Host requests authentication from AP. Then AP send 128-bit nonce. Nonce means some code that can be used only one time and then destroyed. So it cannot be copied, cannot be reused. So one time used and destroyed. Host, that's called nonce. One time what? Nonce, nonce. Nonce means one time. And host encrypts nonce using shared symmetric key. So they are using the same key once they receive nonce from the access points. The access points decrease a nonce and authenticate the host. So by sharing the nonce, so first nonce is given from the AP to the station, which is your laptop, and then you generate a symmetric key, and then return to the access points. Then access points also generate the symmetric key. Therefore, which means they have the same key for that particular connection. So as far as the connection stays, they use that symmetric key. And once it is deassociation, then you have to redo. Okay. So it is not a key distribution mechanism. By using nonce, one time generates, and they use it as far as the communication is alive. So algorithm is this. Host and AP share 40-bit symmetric key. Host appends 24-bit initialization vector, so total the key will be up to 64-bit. So they use 64-bit keys. 64-bit key used to generate stream key. So streaming key is additionally needs to be generated. That key is finally used for encryption. So encryption operation is simple. What is it? There's exclusive OR. Once you have that encryption key, and for each data, you can use it, and this is a cipher. In the example that we did, therefore, at the receiver side, if you have a cipher, then use the same key here. Therefore, you will get DI. The beauty here is that if you have one or the other, original data or cipher, vice versa, and using the same operator, they have the other. That is the beauty. What is the problem? Problem here is the key itself. If a key is compromised, then you lose everything. That was the WEP, right? 64 bits. Out of 64 bits, the real hot core portion of the key is 40 bit. If you have 40 bits, then by iterations, you can break it. That's what it happened, right? Only 40 bits. Now, WPA, they use 128 bit. Bigger than this, but 128 all, that is the secret portion. So compare this to 40, big difference. So idea for RC4 is this. This diagram. Every encryption key, and then pseudo-random number generator generated by nonce, and generates the key here, K. And if you have a plain text, then they do exclusive OR. And then ciphertext will be sent out. This is a simple diagram, but in reality, a little more than that. Protocol itself is this. If you have message M, okay, or plain text B, they're the same, okay. Plain text P. Then you checksum of that plain text P is appended to the P, usually CLC, right? Cyclic redundancy code appended to the plain text. So you have P here. P, that is plain text, and this is cipher P. And using the RC4, you generate the key. Size of key here is 40 bits, and there is an initialized vector, usually 0000. Right? Then that is 26 bits, altogether 64 bits. So one at a time, 64 bits and 64 bits are exclusive operates. It's not yet 128. So upon receipt is reverse step. So here is an example. If you have a message, then CLC is attached to it. Message, any message, for example, cybersecurity at mercy, then there's a message, and then you can attach the CLC. Usually 000. I mean, 3 bits are attached to it. What CLC can do is that it checks the integrity of a message itself. So CLC is not encrypted. That is the weakest point of WEP also. In theory, in the later of this slides, theoretically proves it is not secured. CLC itself is not encrypted, therefore, mathematically, we can guess. If you have two encrypted cipher script, then you can guess some. So together that message goes into RC4 algorithm so that you have key streams and applied to exclusive OR, then that is a cipher script. This will be applied by exclusive OR. Okay, cyber text can be generated by that. And finally, this cyber text is attached by IB initialized vector, so all together. This is not yet a packet. Wireless packets. This is a payload. This itself. That should have a header code, right? This is authentication that we looked at previously. They share the secret distributed out of band. Right. They first challenge. Access points send on nonce to the station, your laptop. Then your laptop generates symmetric key with a random number generation. And once it is successfully done, and then return then nonce to this access point. So that access point also generates the key. So eventually they have the same key. So key is not just a given. Okay, both generates based upon same nonce. So here's the thing. Key 40-bit key is generated. 40 keys generated from random number generation and also nonce, and initialize the vector together. This is 24 bits and key 40 bits, altogether 64 bits. And you have a payload and some CRC, for example, integrity check value. So CRC is typical integrity check, but in general can be used by something else. So example of a ICV is a CRC. And they go together, go to RC4 so that you have payload and CRC. This payload and CRC, this is it. This is encrypted portion, and it attached to the packet header information. You have a header and initialize the vector. See, this is given here. This is not encrypted, but this initialize the vector is playing one of the major role in that encryption process. By looking at the packet, we can guess some because we already know this. And key number. This is encrypted red portion, but this is a packet, WEP frame. By looking at this frame is known. It's a plain text. So header, again, header is decomposed into many different ones, right? It has a version, number, so many others for wireless communications. And IB and key number and encrypted version. For this encryption, if you have the key, then you can decrypt it, right? Supposedly if you have a key, you can decrypt it very quickly, simply by applying exclusive OR. So key generation, this will be discussed according to the algorithm. This is a brief algorithm, but This is real. Okay, real exercise. This exercise will be done. Let me check the time. I think we need to take a break. After break, when you come back, we'll look at this exercise. This is a mathematical exercise, but this is comprehensive exercise. So I want you to stay. Don't go home and come back. Okay? So we'll get to this.